Welcome to Zinc Battery Series video, Part 2, Battery Introduction and Classification. In this introduction, we will first discuss what is a battery, and then we will discuss the battery classification, both in terms of usage and material type. So battery is a device that converts chemical energy to electrical energy. It can have used once or used multiple times. For used once, we also refers to disposable battery or primary battery. For multiple time discharge and discharge battery, we also call it rechargeable or secondary battery. From an use case scenario, battery can be classified as consumer battery, power battery, and energy storage battery. So as the figure shows here, like phones, laptops, they are all called consumer battery. Like electrical vehicles, those battery packs underneath the vehicle we always call them as power batteries. Power battery also refers as mobile BESS, means mobile battery energy storage system. By contrast, in this most right side, they are storage batteries, also referred as stationary batteries. Stationary BESS, which has, as you see, the scale or the number of battery installed are much higher than power batteries. There are 7-dimensional performance evaluation metrics to evaluate batteries to evaluate different type of batteries. So we this include evaluation energy density and charge and discharge capacity and rate. Also cycle life, and as well as safety. No matter what type of battery, we definitely want it be safe and does not catch any fire, right? And we want it low cost. We also want the performance better at extreme temperature, like either hot weather or cold weather. Right? But if we focus on the energy storage battery, the origin line, you will find that there are 3 aspects especially important, because like here shows the cost for ESS requires super low. At least for these 3 types, it's ranked the lowest, so it should be not expensive. It should be cheaper, and also it requires highest safety, and also it requires very longer cycle life. So cyclability is another like a major differentiation factor for ESS, as energy storage system usually have a longer service life, like over 15 years up to 20 years. In this page, we will briefly introduce the battery candidate for energy storage system from battery material type. So as you see from this top pie chart, the dark gray color indicate the lithium-ion battery, which always occupy the largest portion in the ESS market. And then the ranked followed 3 type batteries are sodium-ion, lead acid, and flow batteries. However, each of these type of battery has its associated disadvantages. For example, for lithium-ion, the cost is expensive, and it has safety concern because usually in the lithium-ion batteries electrolyte, it utilizes the flammable organic materials that can cause them to run away, and then for the fire or even explosion or deflagration. So that's a very serious safety issue. Sodium ion, or compared with lithium ion, it usually have relatively low energy density, and it does not as commercialized as lithium ion. But for lead acid, the typical or very straightforward disadvantage is the environmental impact, because it uses very toxic materials. And another one is the cycle life. It's for now, at least, it's a compared with lithium ion currently can reach 10K, but for now, lead acid only about 2.5K a cycle. So this is another disadvantage. And in summary, and or another critical issue that from a supply and demand perspective is all these type of batteries total cannot meet the future global energy needs. Therefore, we definitely need another type of battery that can fit the market or can meet the needs. Here we will focus on zinc battery, but we will talk about why zinc battery is good and why we choose that. But all these issues with the most popular batteries and the energy needs bring us to the zinc battery, which is needed for the development, for the efforts from both researchers, academia, and industry. So let's talk about why zinc batteries. So there are many advantages associated with zinc batteries. The first one, it's cheaper. So this is basically a point that solves the ESS cost issue, right? It's cheaper because of the abundance of zinc on Earth. And by contrast, for the price of lithium-ion battery, the price on 2021, it's about 140 $140 per kilowatt hour. However, for zinc battery, it can be expected to under $100 per kilowatt hour. So this is about a 30% decrease, over 30% decrease on cost side. Then another one is safety, as we mentioned that because unlike lithium ion utilize the organic flammable organic component in the electrolyte. Usually zinc ion battery use water-based aqueous electrolyte. So this will make it more safe. And also it does not have any other toxic material, so it's very environmental friendly. Also, because of the pure zinc metal, the high theoretical capacity of zinc metal, so this is another one can contribute to zinc battery is a field that promising that can need for the research. Last, I want to show you, this is a prediction or an existing data with prediction from the year of 2018 to the year of 2030. So as you can see, there is a significant increased trend for the zinc ion battery. This is a market size are increasing, especially for this blue color region, which represent Asia Pacific region. So the increase in trend is very straightforward and significant. Okay, so in this video, we in summary, we briefly introduce what is a battery and how it can be classified based on the use case or based on its material. Also, we introduce some evaluation metrics that can for different especially for ESS, what are the points that we want to solve, we want to conquer both from the academia and the industry side. Then we focus on the why zinc battery. Zinc battery for ESS, why zinc is promising, why the zinc can match those strict requirement for ESS. In next video, we will give more dive deeper into the zinc battery, and we will talk about what are the current challenges for zinc battery and what are the potential solutions. Thank you for your attention and time.